Good morning, students. Exercise 9.3, second problem, sixth subdivision, we are going to see. Exercise 9.3, second problem, what it is, evaluate the following integrals using the properties of integration. Okay, we'll come to the sixth subdivision. Integral 0 to 1 modulus of 5x minus 3 into dx. You know very well about the modulus function. So, the modulus function can be written as minus of 5x minus 3 if 5x minus 3 is less than 0. So, 5x minus 3 less than 0 means your x is less than 3 by 5. So, when x less than 3 by 5, the modulus of 5x minus 3 answer is minus of 5x minus 3. If 5x minus 3 is greater than or equal to 0, that is your x is greater than or equal to 3 by 5, your modulus of 5x minus 3 is equal to 5x minus 3. Okay, so see now, integral 0 to 1 modulus of 5x minus 3 into dx. This integral I am going to split as 0 to 3 by 5 modulus of 5x minus 3 into dx plus integral 3 by 5 to 1 modulus of 5x minus 3 into dx. So, in this interval 0 to 3 by 5, your modulus of 5x minus 3 is minus of 5x minus 3. So, that's why here I have written minus of 5x minus 3 into dx. From this limit 3 by 5 to 1, so it is greater than 3 by 5 to 1, up to 1, your modulus of 5x minus 3 is equal to 5x minus 3 into dx. Okay, so when you apply this minus inside, so it is minus 5x plus 3. So that's why I have written 3 minus 5x into dx. Okay, so we are going to integrate this. So 3 into dx, the integration is 3x minus 5 is a constant. What is the integration of x dx? It is x squared by 2. Okay, and the limits are 0 to 3 by 5. So the same way, if you integrate, 5x can be integrated as 5x squared by 2 minus the constant 3 into dx can be integrated as 3x, and you have to write the limit 3 by 5 to 1. So first what you have to do, you have to apply the upper limit. So what is upper limit here? It is 3 by 5. So wherever you are having x, you have to apply 3 by 5. So 3 into 3 by 5, that is 9 by 5. Minus 5 into, in the place of x, you have to apply 3 by 5. Here you are having x squared. So 3 by 5 the whole squared. 3 by 5 the whole squared is 9 by 25 divided by 2. So upper limit is over. Next you have to go for the lower limit. Before that you have to write minus in between. So here also you are having x. Here in this term also you are having x. When you substitute x as 0, the two terms getting 0. So the lower limit is 0. First term we have applied the limit. Coming to the second term, the same way we have to apply the upper limit. Upper limit is 1. So in the place of x you have to substitute 1. So the first answer is 5 by 2 minus 3. So next you have to apply the lower limit. So before that you have to write minus. So first 3 by 5. So when you apply here, it is 3 by 5 the whole square. That is 9 by 25. So 5 into 9 by 25 divided by 2 minus, in the place of x, if you apply 3 by 5, 3 3s are 9, 9 by 5. Okay, you see that here 9 by 5, the first term is 9 by 5. You see now the denominator 2. So here also the denominator is 25. So it will be 50. 50 will be in the denominator. So your answer is 5 into, what is it? 5 into 9 by 50. You see that? First term 9 by 5. Second term is minus 5 into 9 by 50 plus, you see now this term is 0. Here 5 by 2 minus 6. If you take LCM, it is 5 minus 6 by 2. So I have written 5 minus 6 by 2. And the same way, you see that here you are having minus. So this minus has to be applied to the two terms. When you apply the first term, it should be in minus. When the second term, the minus is applied, minus into minus plus. So here I have written plus 9/5. So when you simplify the first term, 2 is in the denominator and 25 is also in the denominator. So it is, the denominator is 50. So 5 into 9/50. Okay. So if you cancel 5 and 50, it is 10. Here also 5 and 50, it is 10. 5 minus 6 is minus 1/2. So here the LCM is 10. So this has to be multiplied into 2. So 9 2s are 18. Minus 9. Here it is minus 5, minus 9 and plus 18. So 18 plus 18 is 36. When you add these three, it is minus 23. So when you subtract, your answer is 13/10. Okay, so we'll come to the next problem. That is, the subdivision is 7th subdivision. You see that integral 0 to sine squared x sine inverse of root t into dt plus integral 0 to cos squared x cos inverse of root t into dt. Okay, so I'll take, here there are two integrals. The first integral I'll call it as 1. First I'll consider that alone. So I1 is equal to integral 0 to sine squared x sine inverse of root t into dt. Okay, so see now here I'm going to do the substitution. Your t is equal to sine squared theta. What is in the place of t? I'm going to convert everything in terms of theta. So t is equal to sine squared theta. So here you are having dt. That means you have to differentiate t with respect to theta, or you can differentiate with respect to t also. Here I have done with respect to theta. So what is the differentiation of t with respect to theta is dt by dt is equal to. So here sine square theta, how it will be differentiated? So it is, you have to use the chain rule. So the sine theta has to be kept as x. So it is in the form of x squared. So what is the differentiation of x squared? It is 2x. So that's why 2 sine theta. According to the chain rule, which is kept as x, that has to be differentiated. Which is kept as x, sine theta. So the differentiation of sine theta is cos theta. So dt, the d theta is in the denominator. When you take it to the right side, it will be in multiplication. You know very well the trigonometry identity, 2 sine theta cos theta, that is double angle identity, that is sine 2 theta. So 2 sine theta cos theta can be written as sine 2 theta and the denominator dt into dt. So we have written t is in terms of theta and dt also in terms of theta. Now you are going to change the limit. Your limits are in t. You are going to change in terms of theta. Okay, so first t, what are the limits? So the lower limit is 0 and the upper limit is sine squared x. Now you are going to convert in terms of theta. You see that first t here, it is given t is equal to 0. If you substitute in this relation, in the place of t, you have to write 0. Okay, 0 is equal to sine squared theta. What is it? 0 is equal to sine squared theta. What is it? 0 is equal to sine squared theta. Okay, but what is sine theta? Sine theta is equal to 0. So sine 0 is 0. Sine 0 is equal to sine theta. So therefore sine 0 is equal to sine theta means your theta is equal to 0. So when t is equal to 0, your theta is also 0. Next, t, what is given here? It is sine squared x. So when t is equal to sine squared x, so you see that sine squared x is equal to sine theta. So sin x is equal to sine theta. So therefore x is equal to theta. So here in the place of theta you have to write x. So we have changed the limits in terms of theta. So you call the first integral, that is I1. It is, here you are having 0. When t is equal to 0, theta is 0. So here I have substituted 0. When t is equal to sine squared x, your theta is equal to x. So here I have written x. Here what you are having? Sine inverse of root t. What is root t? It is t is sine square theta. So it is a square root of sine square theta. What is dt? it is sine 2 theta into d theta. So it is written here. Okay, so the next integral 0 to x sine inverse of, what is square root of sine square theta is sine theta into sine 2 theta into d theta. So it's a sine inverse function and sine functions both getting cancelled. So the remaining is theta. So I1 is equal to, what is it? Integral 0 to x theta sine 2 theta into d theta. So I have completed I1. So in the same way, take next integral I2. So what is I2? It is 0 to integral 0 to cos squared x cos inverse of root t into dt. So I have taken this result. Okay. So here the same substitution it will is going to be given. So t is equal to cos squared pi. So the pi 1 I have used theta, here I have used pi. Okay, so everything has to be converted in terms of pi. So here you need dt. So you have to differentiate with respect to pi. So here your answer is dt by d pi. Okay, so here when you differentiate with respect to pi, you have to use the chain rule. So 2 cos pi, and cos pi if you differentiate it is minus sin pi. So here it is minus 2 cos pi sin pi. Where how this d pi has come? It is in the denominator in the left side. So when you bring it to the, when you brought it to the right side, it is d pi. So you know the formula. 2 cos pi sin pi is sin 2 pi. So dt we have found. So next one, what is needed? You have to change the limit also. So limit is in terms of t. So the lower limit is 0 and the upper limit is cos squared x. Okay. So you have to convert the limits in terms of pi. So the relation here you are having. So when t is equal to 0, so if you substitute t as 0, t is equal to 0, 0 is equal to cos squared pi. So cos pi is equal to 0. Cos of which value is 0 means cos pi by 2. So pi is equal to pi by 2. When t is equal to 0, your pi answer is pi by 2. Okay, and come to now, what is t now? It is cos squared x. So when you substitute here, cos squared x is equal to cos squared pi. So from this, x is equal to pi. So here you have to substitute x. So this integral, you take the second term, second result, and it can be written as I2 integral. In the place of 0, pi value is pi by 2. So pi by 2 to x cos inverse of square root of cos squared pi, and what is dt? Minus sin 2 pi into d pi. So square root of cos squared pi is cos pi, and the inverse functions getting cancelled. So the whole answer is pi. So here you are having minus. So the next term I2 can be written as, what is it? Integral pi by 2 to x cos inverse of cos pi into minus sin 2 pi into d pi. So when you calculate this, so the answer is pi. So here you are having minus, so the minus is written in the front. So minus pi sin 2 pi into d pi. So what is your question? So we have to add these two integrals. What is I1 value? So the I1 is nothing but integral 0 to x theta sin theta d theta plus what is I2? This is your I2. Okay. So you see that definite integral is independent of the change of variable. So here integral a to b f of x dx can be written as integral a to b f of y dy. So here the variable is x, here the variable is changed as y. So it is allowed in the definite integral. So using this property, this pi can be changed as theta. So the first integral I have written as it is. In the second integral, using this property, it can be written as integral pi by 2 to x minus, instead of pi, you are taking the variable theta, because integral a to b f of x dx can be written as integral a to b f of y dy. In the definite integral is independent of change of variable. So next, minus theta sin 2 theta into d theta. And next step, in definite integral, if you want to change the limit, you have to write minus in the front. So here the lower limit is pi by 2 and the upper limit is x. I am going to change the limit. So when you change the limit, you have to write minus in between. Already in your question you are having minus. So minus into minus plus. So plus, I am going to change the limit. So integral x to pi by 2 theta sin theta into d theta. So again the next property, 0 to x, and here you are having x to pi by 2. So this can be written as integral 0 to pi by 2 theta into sin theta d theta. So which property here we are using? The property is integral a to b f of x dx can be written as integral a to c f of x dx plus integral c to b f of x dx. So here you are having 0 to x, and here you are having x to pi by 2. So it can be written as integral 0 to pi by 2 theta into sin theta d theta. Okay, so here we are going to use the Bernoulli formula. Otherwise we can go for integration by parts method. Here in this problem I have used Bernoulli formula. So here u has to be taken as theta and dv has to be taken as sin theta into d theta. So u dash u double dash means you have to differentiate u successively. So u dash means you have to differentiate u with respect to theta. So that is 1. That is du by d theta. That is denoted as u dash. So that is 1. So when you differentiate u dash with respect to theta, that is u double dash. So the differentiation of the constant is 0. Here u I have differentiated. Here I have taken dv is equal to sin 2 theta into d theta. So you are going to integrate this. So integral dv as v, which is equal to sin 2 theta. The integration of sin 2 theta with respect to d theta is minus cos 2 theta by 2. And if you differentiate, if you integrate it again, that is v1. So if you integrate v with respect to theta, that is v1. So here minus 1 by 2 is a constant. Cos 2 theta, if you integrate, it is sin 2 theta by 2. So the answer is minus sin 2 theta by 4. Okay, so here I have written the Bernoulli formula. Integral u dv, the product of two terms can be written as uv minus u dash v1 plus u double dash v2 minus etc. Okay, so here you take the integral 0 to pi by 2 theta sin 2 theta into d theta. Here u into v, this is your u, this is your v. So minus theta cos 2 theta by 2, and in between you are having minus u dash v1. So this is your u dash into v1. So here in this term you are having minus, in the formula you are having minus, so it will become plus. So 1 into sin 2 theta divided by 4, and the limits varies from 0 to pi by 2. So first you have to apply the upper limit. So what is the variable is involved? Theta. So in the place of theta you have to apply the upper limit. So minus pi by 2 cos of 2 into pi by 2. So 2 getting cancelled, you are having cos pi divided by 2 plus sin 2 into pi by 2. So sin pi by 4. So upper limit is over. Before moving to the lower limit, you have to write minus in between. So apply the lower limit. Lower limit is 0. So in the place of theta, if you substitute 0, the whole term will become 0. Here you are having sin 2 into 0. So sin 0 by 4. Sin 0 is 0. So the lower limit fully 0. And here you see that minus pi by 2. Cos pi is minus 1 by 2. Sin pi is 0. So this term will become 0. So you will get this. So if you multiply, it is pi by 2 by 2. This 2 also in the denominator, this 2 also in the denominator. So your answer is pi by 4. Okay, so we'll come to the problem number 8. What is that? Integral 0 to 1 log of 1 plus x divided by 1 plus x squared into dx. So here in this problem we are going to substitute x as tan theta. So you are going to differentiate with respect to x. So the differentiation of x with respect to x is 1, and the differentiation of tan theta is secant square theta, and you are going to differentiate with respect to x means it is d theta by dx. So in the dx, 1 into dx is dx is equal to secant square theta into d theta. So x is changed in terms of theta, so the limit also in terms of x, it has to be converted in terms of theta. So first lower limit is 0 and the upper limit is 1. So now you are going to write in terms of theta. So here you have to substitute in the place of x as 0. In the place of x as 0. So what will come? So see now, here x is equal to tan theta. X is equal to tan theta. So first in the place of x as 0, 0 is equal to tan theta. So what value of tan is 0? It is tan 0. So tan 0 is equal to tan theta. So theta is equal to 0. So here x is equal to 0 means your theta also 0. Next x as 1. So if you substitute 1 in the place of x as 1, 1 is equal to tan theta. So this 1 can be written as tan 45 degree, that is pi by 4 is equal to tan theta. So therefore what is it? Your theta is equal to pi by 4. When x is equal to 1, your theta is equal to pi by 4. So here I have substituted. So the whole term, you take the problem 1. So 1 implies integral. In the place of x, 0 means your theta also 0. But x is 1 means your theta is equal to pi by 4. Log of 1 plus, in the place of x you have to write tan theta, divided by 1 plus tan square theta. What is dx? It is secant square theta into d theta. You know the trigonometry identity, 1 plus tan square theta is secant square theta. So secant square theta minus tan square theta is equal to 1. So from that 1 plus tan square theta is equal to secant square theta. The secant square theta and secant square theta getting cancelled. Okay, so what is remaining? Here you will have integral 0 to pi by 4 log of 1 plus tan theta into d theta. So call this is your I. So it has to be integrated. Then you have to apply the limits. So before moving to the integration, here you have to use this property. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x into dx. So x has to be replaced by a minus x. Both the integral values are same. Here in your integral, what is your a? A is pi by 4. So in this integral, in the place of theta, it is going to be replaced as a minus theta, that is pi by 4 minus theta. So here theta has to be written as pi by 4 minus theta into d theta. Okay, here I have written this integral. What is the value of this? I. So I have replaced theta by pi by 4 minus theta, that both the values are same. So this also I am going to call it as I. Okay, so see now log of 1 plus. So it is in the form of tan a plus b. So what is the formula for tan a plus b? Tan a, here you are having tan a minus b. So tan a minus b is equal to, what is it? Tan a minus tan b divided by 1 plus tan a into tan b. So using this trigonometry formula, here your a is pi by 4 and your b is theta. So it is tan pi by 4 minus tan theta divided by 1 plus tan pi by 4 tan theta into d theta. What is tan pi by 4? Pi by 4 is 45 degree. So tan 45 degree is 1. So the numerator is 1 minus tan theta divided by, here this one is written as it is, plus here tan pi by 4 is 1. 1 into tan theta is tan theta. So you are going to take LCM. What is LCM? 1 plus tan theta. So this one has to be multiplied with 1 plus tan theta. So 1 plus tan theta plus 1 minus tan theta. So plus tan theta and minus tan theta getting cancelled. So what is 1 plus 1? 2. So integral 0 to pi by 4 log of 2 divided by 1 plus tan theta into d theta. So here it is in the form of log a by b. So what is log a by b? Log a minus log b. So log 2 minus log of 1 plus tan theta into d theta. So here already we called this is I. So you are going to split as two integrals. The first integral is integral 0 to pi by 4 log 2 into d theta minus integral 0 to pi by 4 log of 1 plus tan theta into d theta. So you just see that. So after substituting x is equal to tan theta, you are getting 0 to pi by 4 log of 1 plus tan theta into d theta is called as I. So here this term is going to be written as I. So this minus I, when you take it to the left side, it is plus I. So I plus I is 2I. 2I is equal to, here you are going to integrate this integral. So log 2 is a constant, so it is taken out. Integral d theta, so the integration of d theta is theta and the limits has to be applied 0 to pi by 4. So log 2 into, when you apply the upper limit is pi by 4 minus lower limit is 0. So here 2I is equal to pi by 4 into log 2. So this 2 has to come to the denominator here. So your I is equal to pi by 8 into log 2. Thank you, students.